Welcome back to the channel, dear students. So we are continuing with the next problem, the relations and functions. In the last class we were solving the problems related to the problems like reflexive, symmetric, transitive based questions we were solving. Let us continue with the given question. So here we have the 13th question. Show that the relation R in the set 1, 2, 3 given by R is equal to an ordered pair 1, 2, 2, 1 is symmetric but neither reflexive nor transitive. This is what we have to prove. We need to prove that the given relation is only symmetric, but it is not reflexive and not transitive. We have to prove. Now to prove this, let us consider the given relation. What is the given relation? The given relation R is having only two ordered pairs, that is 1, 2 and 2, 1. And the given set of elements A are 1, 2, 3 under the set A. So under this set, we need to cross check whether the relation R is only symmetric, and we have to prove that it is not reflexive and not transitive. Now to prove this, let us refer the definition of reflexive. When do we say that the given relation is reflexive? When we have all the identical ordered pair for the given elements of set A. But here we don't have not even a single identical ordered pair. Therefore we can say that the given relation is not reflexive. We can give a reason. Since 1, 1 does not belongs to R, therefore R is not reflexive. Only one counter example is sufficient to say that the given relation is not reflexive. One example if you give, that is sufficient. So that's what I am saying. So we have an elements of set A 1, 2, 3. To say that the given relation is reflexive, we should have 1, 1, 2, 2, 3, 3. But we don't have not even a single identical ordered pair. So I have given one example by saying that it is a not reflexive. Since 1, 1 does not belong to R, therefore R is not reflexive. Now let us move on to symmetric condition. When do we say that the given relation is symmetric? To say that the given relation is symmetric, we should have non-identical ordered pair and the reverse of the same. Which I mean to say, if A, B belongs to R, then B, A should also belongs to R. So here we have 1, 2 belongs to R, which implies that 2, 1 also belongs to R. Therefore, the relation R is symmetric relation. Finish. R is symmetric relation. And the last one is transitive. Can we say that the given relation is transitive relation? Our intention is to prove that the given relation is not transitive. Why it is not transitive? Let us see. So here we have an ordered pair 1, 2 belongs to R and 2, 1 belongs to R. See, these two ordered pairs are in the form of A, B and B, C format. When we have A, B and B, C in the relation R, we should have A, C. But here we don't have A and C. Where A and C is nothing but 1, 1. Here 1, 1 does not belongs to R. Therefore, the relation R is not transitive. Therefore, the relation R is not transitive. Hence we proved. So this is how we prove. The given problem is only symmetric, but it is not reflexive and not transitive. I hope you have understood. Let us move on to the next question. Okay, dear student, we have a next question, that is determine whether each of the following relations are reflexive, symmetric, transitive. And the first sub question is if a relation R in the set A is equal to 1, 2, 3, 4, 5, so on up to 14, defined as R is equal to an ordered pair x, y such that 3x minus y is equal to 0. See, when I have given these type of problem, the problem will become very simple because till now we were solving the problems in general. But when they give the elements which is of this form, the problem becomes very simple to solve it. Now let us see how to solve the given question. Now to solve the given question, what we can do is we need to take the elements only from the given set A. Set A elements are only from 1 to 14. So here we can take value of x and y only from these elements. Both x and y should belong to the given set. So here what you can do is we can frame the elements of the relation R. Then we can cross check whether the given relation is reflexive, symmetric, transitive or not. So here the given condition is 3x minus y is equal to 0 is given. 3x minus y is equal to 0 is given. So if I take y to the other hand side, we get y is equal to 3x or 3x is equal to y we will get. Accordingly I had written. Now I will take the input value. What is the input value? Our input and output both should be from the given set A. So I can take the value of x as 1. When x is equal to 1, y value will become 3 into 1, which is nothing but 3. When x is equal to 2, y value will become 3 into 2. 3 into 2 is nothing but 6. When x is equal to 3, y value will become 9. When x is equal to 4, y value will become 12. When x is equal to 5, y value will become 15. See, we don't have 15 here. In the given set A, we don't have 15, which means the elements are only from 1 to 14 is given. We don't have 15. As the value of x increases from x is equal to 6 onwards, y value also will increase more than 15. Because I can give some more example. When x is equal to 6, y value will become 3 into 6. 3 into 6 is nothing but 18. When x is equal to 7, y value will become 7 into 3. 7 into 3 is 21, and so on. As you increase the value of x from x is equal to 5 to infinity, y value also will increase from 15 to infinity. But our limitation is only from 1 to 14. So only these many ordered pair we can write. So the remaining ordered pair we cannot write. Clear? The remaining ordered pair we cannot write because these elements 15, 18, 21 and so on, they are not there in the given elements of set A. So we can write the elements of the relation R, which is of the following form. When the value of x is 1, 1 comma 3, ordered pair we are framing x comma y, 1 comma 3, 2 comma 6, 2 comma 6, followed by that 3 comma 9, and then 4 comma 12. See, this is very easy, as I told you that when we have the elements which is of this form, it is very easy to predict whether the given relation is a reflexive, symmetric or transitive. Now see, we have written the elements of the relation R under the set A is equal to 1 to 14. Now we need to predict, or we need to cross check whether the given relation is reflexive, symmetric or transitive. We all know the definition of reflexive, symmetric and transitive. Since the set A has 14 elements, which means we should have all the 14 identical ordered pair for the given elements of set A. Then only we can say that the given relation is a reflexive relation. Since we don't have not even a single identical ordered pair, so I am giving the example. Since 1 comma 1 does not belongs to R, therefore R is not reflexive. Finish. Because we should have 14 identical ordered pair. If any one ordered pair is missing among them, we can immediately say that the given relation is not reflexive. So I am giving one counter example to say that the given relation is not reflexive. Now moving to the next one, that is symmetric relation. Can we say that the given relation is symmetric? Let us cross check. See, we have many more non-identical ordered pair, but we don't have reverse of the same. For example, if I say that 1 comma 3 belongs to R, but 1 comma 3 belongs to R, which implies that 3 comma 1 does not belongs to R. 3 comma 1 does not belongs to R. Therefore, R is not symmetric. Therefore, R is not symmetric. And the last one is transitive. Transitive condition, I hope you all know very well. When we have A comma B and B comma C, then A comma C should be there. Then only we can say that the given relation is transitive relation. See here, A comma B and B comma C format, we have the two ordered pair, like 1 comma 3 belongs to R and 3 comma 9 belongs to R. We have the two ordered pair which is in the form of A comma B and B comma C format. A comma B and B comma C. Then what should be A and C? A and C should be 1 comma 9. You can observe from the given ordered pair in the relation R, we don't have 1 comma 9. Do we have that 1 comma 9? No. Since we don't have 1 comma 9 in the given relation R, therefore we can say that the relation R is not transitive. Finish. This is what we wanted to cross check whether the given relation is reflexive, symmetric or transitive. Clear? R is not transitive relation. I hope you have understood. Let us move on to the next question. Okay, you can observe the next sub question we have. The relation R in the set n of natural number. Under the natural number, defined as R is equal to an ordered pair x comma y such that y is equal to x plus 5 and x is lesser than 4. See, here our set A elements are natural number. Set A elements are natural number, and we have one more condition that the value of x must be lesser than 4. Natural number and less than 4. Both the condition to be considered. So here I will consider, let set A is equal to natural number. What are natural number? 1, 2, 3, 4, 5 and so on up to infinity. But here, since x is lesser than 4, we can consider only the elements of set A as only 1, 2, 3. Clear? So in the beginning, they had given in the set n of natural number, it was given in the set of natural number. So we have to consider the set A is equal to natural number. We all know natural numbers are from 1 to infinity. Accordingly, I had considered. But in the condition, in the relation R, one more condition is given very clearly, that the value of x must be lesser than 4. It can never be greater than, or it can never be equal to 4. It is strict inequality. We can say lesser than means it has to be less than 4 only. Okay, and the natural numbers are starting from 1 and ending at infinity, but we need to take the two condition, natural numbers and x must be lesser than 4. Natural numbers and x must be lesser than 4. That means the elements of natural numbers under x lesser than 4 is only 1, 2, 3 we will get. And here the relation R is given as, y is equal to x plus 4. Set of all ordered pair x comma y such that y must be equal to x plus 5 is given. Okay. Under this, what are the ordered pair we will obtain? Let us identify. Then we will cross check whether the given relation is reflexive, symmetric or transitive or not. Now I am considering the given condition. What is the given condition? Y is equal to x plus 5 is given. When x is equal to 1, what is the value of y? Y will be equal to 1 plus 5 we will get. 1 plus 5 is nothing but 6. When x is equal to 2, y is equal to 2 plus 5. Just I am replacing the value of x by giving the input as a 1, 2, 3. That's it, nothing else. 2 plus 5 is nothing but 7. When x is equal to 3, the value of y will become 3 plus 5, which is equal to 8. So from this, we can write the set of ordered pairs as a relation R, that is 1, 6, 2, 7 and 3, 8. So now we need to cross check whether the given relations are reflexive, symmetric or transitive or not. See, we can say that the given relation is not reflexive. It is not reflexive. What is the reason? Because we should have all identical ordered pair for the given elements of set A. 1, 1, 2, 2, 3, 3 should be there, but we don't have. It is not reflexive since 1, 1 does not belongs to R. Now, when we check for the condition symmetric, we can say that the given relation is not symmetric. What is the reason? Because we all know very well that to say that the given relation is symmetric, if A, B belongs to R, then B, A should also belongs to R. So here you can observe 1, 6 is non-identical ordered pair which is belongs to R, but we don't have 6, 1. So then and there only we can say that since 6, 1 does not belongs to R, we can say that the given relation is not transitive. Now we need to think about the this is not symmetric. Now we need to think about transitive condition. Can we say that the given relation is transitive? Check it once. See, when do we say that the given relation is transitive? If we have two ordered pairs in the form of A, B and B, C belongs to R, then only we need to cross check the third element or the third ordered pair, that is A, C is there or not. But here we don't have a two ordered pair in the form of A, B and B, C. So as we have already discussed in the definition of transitive relation, if we don't have any two ordered pair in the form of A, B and B, C, then we can immediately say that the given relation is transitive relation. Suppose if I consider from the first order pair, A, B is 1, 6 and we don't have other ordered pair which is starting from 6. So we can say that under this particular element we can say that it is transitive. Let us cross check for the remaining two ordered pair as well. We have A, B as a 2, 7 and we don't have B, C which is starting from 7. So still by taking 2, 7 as a first ordered pair, we can say that the given relation is transitive relation. And then again 3, 8. 3, 8 is to be considered as a B and we don't have B, C which is starting from 8. So we can say that the relation R is transitive relation. Relation R is transitive. Finish. We have completed the given question. I hope you have understood. Let us move on to the next question. We have a next third sub question, that is the relation R in the set A is equal to 1, 2, 3, 4, 5, 6 defined as a relation R is equal to an ordered pair x, y such that y is divisible by x is given. So here it is very clear. The set A elements are 1 to 6 and the given condition is y should be divisible by x. Y should be divisible by x. So first we will write the elements of the relation R under the given condition. So here y value must be divisible by x. Okay. Then what are the ordered pair we can write for the given elements of set A? We can write 1, 1. Here x and y both are same and I can say that y is divisible by x. That means 1 is divisible by itself, which is true. Like that only we can write all the identical ordered pair, that is 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Yes, finish. Identical ordered pair we have written, and this one will give you very much clearly the clarity that y value is divisible by x, which is true. Then we will write some more ordered pair, that is non-identical ordered pair under the given condition y is divisible by x. So can I write 1, 2 where 2 is divisible by 1, which is true, and then 1, 3 is divisible by 1, 1 comma 4, 4 is divisible by 1, 1 comma 5, 5 is divisible by 1, and 1 comma 6. So starting from 1, I have written all the possible ordered pair. If I start from 2, 2 is divisible by 2, which is true, which we have already noted. Then even we can write 2 comma 4, 4 is divisible by 2, and 2 comma 6, 6 is divisible by 2. Similarly, if I start from 3, I can say 3 comma 6. If I say from 4, 4 is only one possibility we can write, that is 4 comma 4, which we have already written, and even 5 comma 5, 6 comma 6 also we have written. So these are the ordered pair which will be possible. So from these ordered pair, we need to cross check whether the given relation is reflexive, symmetric, or transitive. So obviously we can say that the given relation R is reflexive because since it satisfies A comma A belongs to R for all A belongs to set A. We have all identical ordered pair for the given elements of set A. You can observe 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, 6 comma 6. We have all identical ordered pair for the given elements of set A. Finish. So we can say that the given relation is reflexive. Can we say that the given relation is symmetric? I don't think so. So because R is not symmetric, the reason is we have non-identical ordered pair, but the reverse of those ordered pairs we don't have. For example, I can say that 1 comma 2 belongs to R. Does 2 comma 1 belongs to R? No. So that's what I'm saying. R is not symmetric since 1 comma 2 belongs to R, but 2 comma 1 does not belongs to R. Can we say that the given relation is transitive relation? Let us cross check. Can we say that the relation R is transitive or not? So now to check the given relation R is transitive or not, we have to cross check whether the given elements are in the form of A comma B and B comma C or not. And then we will cross check whether A comma C is there or not. For example, if I consider 1 comma 2 and 2 comma 4, we have 1 comma 2 and 2 comma 4, which is in the form of A comma B and B comma C format. Then A comma C should be 1 comma 4. That 1 comma 4 is already we have written, so it is transitive. And then even if I consider 1 comma 2, 2 comma 6, A comma C will become 1 comma C, again we have written. And then 1 comma 3, 3 comma 6, but we don't have 1 comma, okay, 1 comma 6 is also there. We can consider. That means the given relation is satisfying transitive relation. Cross check for each and every element, not only 1 or 2 ordered pair. So yeah, we can say that in this case, we can say that the given relation R is transitive relation. In this condition, we can say that the given relation R is transitive because it is satisfying the given condition for the transitivity. Because when A comma B and B comma C belongs to R, obviously the given relation will become transitive relation. So I hope you have understood the given question with the solution. Let us move on to the next problem. Okay, we have a next sub question, that is relation R in the set Z of all integers defined as R is equal to an ordered pair x comma y such that x minus y is an integer. The difference between the two numbers is integer that they are saying. We need to cross check whether the given relation is reflexive, symmetric, or transitive or not. So for this one, we cannot write the ordered pair because Z is nothing but integers, and integers are not finite elements. It has infinite number of elements. We have the negative numbers as well as positive, including 0. So what are integers? The integers are 0, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 5, so on up to plus or minus infinity we can say. So under these elements, writing the ordered pair is not possible because when the set has infinite number of elements, for the infinite number of elements we cannot write a relation R because we will get infinite number of ordered pair. So in general only we have to prove this as we used to prove the previous problems. So here, if I consider all the identical ordered pair will satisfy, we can say that the relation R is reflexive. Why? You can observe here. We can observe here. When I take the first element and the second element are one another the same, the difference between those two elements will be 0, and 0 is an integer. Suppose if I say let A comma A, since A comma A belongs to R, which implies that A minus A is an integer, which is true, correct? No, the difference between A minus A is 0. 0 is an integer, which is true. Therefore, we can say that the given relation is a reflexive relation. Finish. Now move on to the next one, that is Symmetric. When do we say that the given relation is symmetric? Let us cross check. Now, in general only I am trying to prove, because it has infinite number of elements. If I assume, let x comma y belongs to R, what does it mean? It means that x minus y is an integer, If x minus y is an integer, means obviously when we find the value of y minus x is also an integer only, we will get. We never bother about the positive value or negative value, whether you are getting integer value or not, that we are cross checking. I will give an example. Assume we have 2 minus 3. What is 2 minus 3? Minus 1. This minus 1 is an integer. Similarly, if I take 3 minus 2, we get 1 only. That 1 is again an integer only, right? We never bother about these two are one another the same or not. And our intention is not to check whether these two are same or not. Our intention is the difference between the two number is an integer or not, that we need to consider. According to that, y minus x is also an integer only, we will get an integer, which means what we can say, this implies that the value of b comma a is also belongs to R. Therefore we can say that R is symmetric relation. Clear? R is symmetric relation. Similarly, when we move on for transitive relation, 100% this one will satisfy, because we have already observed this type of problem. So we can say that here x comma y belongs to R and y comma z belongs to R, which means that x minus y is an integer, and y minus z is an integer. The sum of these two means x minus y plus y minus z is equal to, we get x minus z only, is also an integer only, we will get, is also an integer. From this we can say that x comma z also belongs to R. This implies that x comma z also belongs to R. From this we can conclude that the given relation is also a transitive relation. Here it is not necessary to prove, but it is a kind of proof only I have written. I hope you have understood how the given relation is reflexive, symmetric and transitive. Since the given relation is reflexive, symmetric and transitive, we can say that the relation R is equal to an ordered pair x comma y such that x minus y is an integer under integers is an equivalence relation. So I hope you have understood this. We will move on to the next question. We have the next question, that is, check whether the relation R defined in the set A 1, 2, 3, 4, 5, 6 as R is equal to an ordered pair A comma B such that B is equal to A plus 1 is reflexive, symmetric and transitive. We need to cross check whether the given relation is reflexive, symmetric or transitive. So let us consider the given condition. Here the given condition is B is equal to A plus 1 is given, and here set A elements are given as 1, 2, 3, 4, 5 and 6. Okay. Now let us take the elements A as a 1, 2, 3, 4, 5, 6, and we know very well that both A and B should be from the given elements of set A only. It cannot be beyond that. Accordingly, if I take value of A is equal to 1, the value of B will become 1 plus 1 is nothing but 2. When A is equal to 2, value of B will become 2 plus 1 is nothing but 3. When A is equal to 3, value of B will become 3 plus 1 is 4. When A is equal to 4, B value will become 4 plus 1. Just I am replacing the value of A by these input. Okay. Accordingly, I am finding the value of B as well. So B is equal to 5 we will get. When A is equal to 5, value of B will become 5 plus 1 is equal to 6. See here, only maximum till 6 we have. If I take the value of A is equal to 6, we get the value of B is equal to 6 plus 1. 6 plus 1 is nothing but 7. But here this 7 is not there in the given set A. So we cannot take the value of A as a 6. Clear? Accordingly, we can write the elements of relation R. What are the elements of relation R? We can say 1, 2 and 2, 3, then 3, 4, 4, 5, 5, 6. I cannot write 6, 7 because 7 is not there in the given set A. So from the given elements of the relation R, it is very clear that the relation R is not reflexive. As you can observe, we don't have identical ordered pair for all the elements of set A. And I will give one counter example. Since 1, 1 does not belongs to R. Give any one example that is sufficient to say that the given relation is not reflexive, not symmetric and not transitive. And moving to the next condition, that is for symmetric, and I can say that the relation R is again not symmetric, because you can observe we have many more non-identical ordered pair, but we don't have, it's a reverse, which I mean to say, if we have 1 comma 2 belongs to R, we should have 2 comma 1 belongs to R, but this 2 comma 1 does not belongs to R. Therefore we can say that the given relation is not symmetric. And even we can say that the given relation is not transitive as well. You can observe why it is not transitive. Can you predict why it is not transitive? What could be the reason that I am saying that R is not transitive? Can you think? It is very simple, dear students. You can observe the two ordered pair which is in the form of A comma B and B comma C, and cross check immediately whether A comma C is there or not. So here we have 1 comma 2 belongs to R and 2 comma 3 belongs to R, but we don't have A and C, which is nothing but 1 comma 3. 1 comma 3 does not belongs to R. Therefore we can say that the given relation is not transitive, which means that finally we can conclude that the given relation is neither reflexive nor symmetric nor transitive. Hope you have understood. Let us move on to the next question. We have next question, dear students. Show that the relation R in R, relation under real number. Okay, the meaning of R in R is nothing but the relation under real number is defined as R is equal to an ordered pair A comma B such that A is less than or equal to B is reflexive and transitive but not symmetric. We need to prove that the given relation is reflexive and transitive, but it is not symmetric. This is what we have to prove. Okay, now to prove this, let us consider in general, if I take for reflexive, let us assume A comma A belongs to R. What do you mean by A comma A belongs to R? The meaning of this one is A is lesser than or equal to A. Can we say that A is equal to A? Yeah, it is, which means it is true. A is less than or equal to A, which is true. Therefore, we can say that the relation R is reflexive relation. Finish. We have proved that the given relation R is reflexive, and I am not taking any example. Even if you take example, it will satisfy, but we need to prove that the given relation R is reflexive for all the real numbers. If you take example, how many examples you can take? Hardly 1, 2, 3, 4, maximum 10. But under real numbers, we have infinite number of elements from minus infinity to infinity. So never take example. Instead, better you prove in general only. Okay, so since A comma A belongs to R, which implies that A is less than or equal to A, which is true, therefore we can say that the given relation R is reflexive. Okay, the first one is done. Now moving on to the transitive relation. Before that, I will consider symmetric. When do we say that the given relation is symmetric? Let us assume A is less than or equal to, let A comma B belongs to R. If I take A comma B belongs to R, let us assume let A comma B belongs to R, which means A is less than or equal to B. Okay, or else better I will take one counter example to make quick answer. Let 1 comma 2 belongs to R. Both 1 and 2 belongs to real number only. 1 comma 2 belongs to R, which means that 1 is less than or equal to 2, which is true. Okay, which is true. But if I take reverse of this one, 2 comma 1, can we say that 2 is less than or equal to 1? 2 is greater than 1, so it is not satisfying, which means what we can say, 2 comma 1 does not belongs to R. So from this what we can conclude, therefore the relation R is not symmetric. Finish. R is not symmetric. And then the last one is transitivity. Let us cross check for transitive condition. So I guess we can say that the given relation is transitive. Let us see. In general only I will prove. Let A comma B belongs to R and B comma C belongs to R, which means A is less than or equal to B and B is less than or equal to C. From this we can say that A is also less than or equal to C. This implies that A comma C belongs to R, we can say. So finally we can conclude that since A comma B belongs to R and B comma C belongs to R, which implies that A comma C is also belongs to R. Therefore the relation R is transitive relation for all the real numbers. So we can say that the given relation is, hence we have proved that the given relation R is reflexive and transitive, but it is not symmetric. Hope you have understood. We'll move to the next question. Okay, dear students, next we have the two questions. I am taking both the questions at a time because for both the questions we can write a single answer. For both the questions we can write single answer. So let us see both the questions once. Let us understand what exactly the question is given. So in that the first question is, show that the relation R in R under relation real number defined as R is equal to an ordered pair A comma B such that A is less than or equal to B square. A is less than or equal to B square is neither reflexive nor symmetric nor transitive. We need to prove that the given relation R under real numbers under the given condition A is less than or equal to B square is neither reflexive nor symmetric nor transitive. This is what we have to prove in the first question. In the second question, we need to check whether the relation R in R defined by R is equal to an ordered pair A comma B such that A is less than or equal to B cube is reflexive, symmetric or transitive. In the second question, we need to check whether the given relation is reflexive, symmetric or transitive. I hope you have got an idea for both the questions. The first question is to prove that the given relation is neither reflexive nor symmetric and not transitive. And in the second question, we have to check. Since I said in the beginning itself, for both the questions we have same solution, which means for both A less than or equal to B square and A less than or equal to B cube, we can say that both are neither reflexive nor symmetric nor transitive. How it is not? Let us see with a counter example. So for the first sub question, when the relation R is equal to, or whether it is for the first question or the second sub question, both I am giving the same answer. Okay, let us cross check for reflexive. So here, since they are saying that under real numbers, if you take integers 100%, it will satisfy. 1, 1, 2, 2, 3, 3, 4, 4. If you take like this 100%, it will satisfy. Since it is real number, we need to check in a different way. So let us take fractions here. So if I take 1 by 2, 1 by 2, the given condition will not satisfy. I'll let you know how it is. 1 by 2, 1 by 2 belongs to R. If I say the condition is given very clearly that A is less than or equal to B square is given. 1 by 2 is less than or equal to 1 by 2 the whole square we will get. Value of 1 by 2 is 0.5 is less than or equal to 1 by 2 the whole square is nothing but 0.5 the whole square we will get, which is nothing but 0.25. Here 0.5 is lesser than 0.25. Yeah, it is. So here the given condition is not satisfying because 0.5 is not lesser than 0.25. Actually, the 0.5 is greater than 0.25. Since the condition is not satisfying, therefore we can say that 1 by 2, 1 by 2 does not belongs to R. Therefore the relation R is not reflexive. Finish. Clear? For both the question we can consider the same. This is for the first question. I will write the solution for the second question here. If 1 by 2 is not less than or equal to 1 by 2 the whole square, does 1 by 2 is less than or equal to 1 by 2 the whole cube? No, not at all. So here also we can say 1 by 2, 1 by 2 does not belongs to R. Therefore, R is not reflexive. Finish. We have proved that the given relation is not reflexive because 1 by 2 is not less than or equal to 1 by 2 the whole cube. Clear? Now moving to the next one, that is symmetric. When do we say that the given relation is symmetric? To say that the given relation is symmetric, if A comma B belongs to R, then B comma A should belongs to R. So I will take one counter example to say that the given relation is not symmetric in both the cases. For example, if I take 1 comma 2, I can say that 1 comma 2 belongs to R because 1 is less than or equal to 2 square, which implies that 1 is less than or equal to 4. That is true. Okay, but if I take its reverse as a 2 comma 1, does 2 comma 1 belongs to R? Let us cross check. 2 is less than or equal to 1 square, which implies that 2 is less than or equal to 1. Is it true? 2 is not less than or equal to 1. This is false. Okay, this is false. 2 is not less than or equal to 1. 2 is not less than or equal to 1. So we can say that 2 comma 1 does not belongs to R. Very simple. 1 comma 2 belongs to R and 2 comma 1 does not belongs to R. Therefore, R is not symmetric. Similarly, here also under the condition for the condition A is less than or equal to B cube, also I can prove the same. 1 comma 2 belongs to R, which implies that 1 is less than or equal to 2 cube, which is 1 is less than or equal to 8. That is true. But if I take the reverse of this, 2 comma 1, I can check that 2 is less than or equal to 1 cube, which implies that 2 is less than or equal to 1 we are getting. 2 is not lesser than or equal to 1. So we can say that 2 comma 1 does not belongs to R. When you are writing in your examination, only if you write this much, that is sufficient. 1 comma 2 belongs to R, but 2 comma 1 does not belongs to R. Therefore, the relation R is not symmetric. Better you write only so much. Even here also we can say that same. For A is less than or equal to B cube. 1 comma 2 belongs to R and 2 comma 1 does not belongs to R. Therefore, R is not symmetric. R is not symmetric. Now the condition will come for transitive. Many students will struggle to remember the same or to give a counter example for transitive relation. To say that the given relation is not reflexive, not symmetric, not transitive. I am giving one single solution for both the questions. Single solution for both the questions. Whether they are giving A is less than or equal to B square or A is less than or equal to B cube. Never worry. Write the same solution for both the question. You will get full marks. So let us see what is that solution. When do we say that the given relation is transitive? If A comma B and B comma C belongs to R, then A comma C should belongs to R. That means we should take the two ordered pairs, which is in the form of A comma B and B comma C, and we need to prove that A comma C does not belongs to R. Then only we can say that the given relation is transitive relation. So here I am giving one simple ordered pair. Remember this: 4, 2 and 3 by 2. Take these three elements. These three elements are in a decreasing order. 4, 2, 3 by 2 is nothing but 1.5. 4, 2, 3 by 2. That means these are the values of A, B and C respectively. Okay, A, B, C respectively. Now we need to take the two ordered pair in such a way that A comma B and B comma C should belongs to R. The condition should satisfy. So I am taking 4 comma 2 belongs to R and 2 comma 3 by 2 belongs to R. What does it mean? It means that 4 is less than or equal to 2 square, which is true. Again here 2 is less than or equal to 3 by 2 is nothing but 1.5. 1.5 the whole square. You should know the value of 1.5, then only you will get to know whether 2 is really lesser than or equal to 1.5 the whole square or not. The value of 1.5 the whole square is 2.25. Okay, so which is true. Again here also we can say it is true. 2 is less than or equal to 2.25. This is also true. That means we can say that 4 comma 2 and 2 comma 3 by 2 are belongs to R, which means here our ABC value are 4, 2, 3 by 2 respectively. A comma B and B comma C. We have A comma B and B comma C. But now we need to cross check whether A comma C is belongs to R or not. But we need to prove that here A comma C does not belongs to R. Then only we can say that the given relation is not transitive, because the first question was given very clearly to prove that the given relation is neither reflexive nor symmetric and not transitive. Accordingly, I am trying to prove. Now I will take the value of A and C as 4 and 3 by 2. 4 and 3 by 2. Now cross check whether this A comma C is it belongs to R or not. Now I will check the condition for A is less than or equal to B square. 4 is less than or equal to 1.5 the whole square, because the given condition is A is less than or equal to B square is given. Now if I cross check, the value of 4 is less than or equal to 1.5 the whole square. What is 1.5 the whole square? 1.5 the whole square is nothing but 2.25. Clear? 2.25. So from this it is very clear that the value of 4 is not lesser than or equal to 2.25, which means 4 comma 3 by 2 does not belongs to R. Therefore the relation R is not transitive. Therefore the relation R is not transitive relation. Clear? I hope you have understood, and I will explain now for A is lesser than or equal to B cube. Now as I told you the same solution for both the questions. Now I am proving for A is less than or equal to B cube. Same ordered pair you can consider for transitivity for A is less than or equal to B cube. Okay, so here I will take 4 comma 2 belongs to R and 2 comma 3 by 2 is belongs to R. Okay, what does it mean? It means that 4 is less than or equal to 8 because 2 cube, which is true. Similarly, 2 is less than or equal to 3 by 2 the whole cube. 3 by 2 the whole cube is nothing but 1.5. 3 by 2 is 1.5. 1.5 into 1.5 into 1.5. If you multiply 1.5 3 times, you will get 3.375. You will get. If you want, you can cross check. And it is very clear that the value of 2 is lesser than 3.375, which is true. Okay. And now I need to cross check whether A comma C, is it belongs to R or does not belongs to R? Our intention is to prove that it is not belongs to R. I will let you know how it is. Now I am taking 4 comma A comma C ordered pair, 4 comma 3 by 2. So this implies that 4 is less than or equal to 3 by 2 the whole cube. 3 by 2 the whole cube, just in the previous step only we had written, that is 3.375. Now you tell me, does 4 is lesser than 3.375? No, 4 is greater than 3.375. So we can conclude here very clearly that the value of 4 comma 3 by 2. This implies that 4 comma 3 by 2 does not belongs to R. Here, therefore, R is not transitive relation. I hope you have understood. This is one of the easiest solution, my dear students. Even when I was learning this particular problem in the beginning, I used to think very much and I used to apply. I used to take my own example as 1, 2, 3 or something and all, and I used to waste my time like anything. But I suggest you, never waste your time and never do error and trial method in your examination. Because in our examination, we have only 3 hours. We need to utilize that 3 hours in a proper way. So that means we have to be prepared for these type of problem in advance. So when we have A is less than or equal to B square and A is less than or equal to B cube, be prepared with the solutions that if you take the value of A, B, C as 4, 2, 3 by 2 respectively, 100% you can easily prove that the given relation is neither reflexive nor symmetric nor transitive. I hope you have understood. Let us move on to the next question. Okay, dear students, we have another question. Like, give an example of a relation which is symmetric but neither reflexive nor transitive. I mean, there are 5 sub-questions are given. There are 5 sub-questions are given, and we should give an example for each of the relation. Okay, let us see the relation one by one. For the first sub-question, what is the first sub-question that they are saying? Before first sub-question or the second sub-question, I told you very clearly that to say that the given relation is reflexive, symmetric or transitive, we should take one set. So I am assuming let A is equal to 1, 2, 3. Here under this set, I am about to give an example for the given sub-questions. The first sub-question is, we need to say that the given relation is symmetric. We need to give an example for the given relation must be symmetric but neither reflexive nor transitive. Okay, see here they are saying that it is symmetric. What do you mean by symmetric? If you have non-identical ordered pair, the reverse of that non-identical ordered pair should be present. So I can say for the first sub-question, R1 is equal to 1, 2 and 2, 1. You can observe here we have one non-identical ordered pair and the reverse of the same. So this becomes symmetric. Can we say that it is reflexive? It is not reflexive because we don't have all the identical ordered pair for the given elements of set A. And it is not even transitive because we have A comma B and B comma C format, but A comma C is 1, 1, which is not there. We can say that the given relation is symmetric but neither reflexive nor transitive. First one is done. Now moving to the second one. Second sub-question is given as the relation R must be a transitive, but it should not be reflexive and it should not be symmetric. Very simple. Write any one ordered pair to say that the given relation is transitive. I can say 1, 2. If I write only 1, 2, the given relation will become transitive because we don't have second ordered pair B comma C. We have only A comma B. We don't have B comma C. So therefore we can say that it is transitive. Does the relation is reflexive and symmetric? Not at all. To say that the given relation is reflexive, we should have all the identical ordered pair. We don't have that identical ordered pair. So we cannot say that the given relation is reflexive. To say that it is symmetric, for every non-identical ordered pair, the reverse of that non-identical ordered pair should be there. We have one non-identical ordered pair, but I am not writing its reverse to say that it is not symmetric. So we are done with second sub-question as well. Moving to the third sub-question. What is third sub-question? It has to be reflexive and symmetric, but it is not transitive. It should be reflexive and transitive. So what we can say for the third sub-question? Since it is reflexive means we should write all the identical ordered pairs. What are identical ordered pairs for the given elements of set A? We can write 1, 1, 2, 2 and 3, 3. Okay, finish. I can say that the given relation is reflexive and even it is symmetric as well. Can we say that it is transitive? If you write only these 3 ordered pair, it will become transitive as well. Because we don't have an ordered pair in the form of A, B and B, C. So better I will include 1, 2 and 2, 1. Can I? 1, 2 and 2, 1. Then again still it is transitive as well. 1, 2, okay. Followed by that 2, 3 and 3, 2. Can I? 1 comma 2, 2 comma 3, 1 comma 3. Okay, yeah. See, in this case, what we can say is the given relation from the first three ordered pair, the given relation will become reflexive. No doubt in that. Okay. Now, from the remaining these four ordered pair, 100% it will become symmetric relation because we have the two non-identical ordered pair and the reverse of those two. We have it. Now, when it comes to not transitive, we need to prove that the given relation is not transitive. So, to say that the given relation is not transitive, you can consider 1 comma 2 and 2 comma 3. Is in the form of a comma b and b comma c format. When we have a comma b and b comma c, we should have a comma c as well. What is a comma c from this ordered pair? 1 comma 3. But we don't have 1 comma 3 and we are not writing it. Therefore, we can say that the given relation is not transitive. I hope you have understood. Clear? And you may be thinking that, sir, it is satisfying for 1 comma 2 and 2 comma 1, 1 comma 1. We should say that the given relation is transitive for every ordered pair, not only for 1 or 2. It should satisfy for every ordered pair. When I consider a comma b and b comma c as 1 comma 2 and 2 comma 3, a comma c will become 1 comma 3. That 1 comma 3 is not belongs to R. Therefore, we can say that the given relation is not transitive. So we are done with third sub question. Moving to the fourth sub question. What is fourth sub question? They are saying that it has to be reflexive and transitive. It should be reflexive and transitive but not symmetric, it seems. Okay. So I will say R4. It has to be reflexive means we should have all identical ordered pair 1 comma 1, 2 comma 2 and 3 comma 3. And then it has to be transitive means yes, we can write only so much, but it is not symmetric. We need to prove that it is not symmetric. If I leave it here, it will become symmetric as well. I will include 1 comma 2. Can I say that the given relation is reflexive and transitive? Think about it. So from these three, we can say that the given relation is reflexive. Okay. From these three, first three ordered pair, we can say that the given relation is reflexive. And is it transitive? Of course, it is transitive. 1 comma 1, 1 comma 2. These two ordered pairs are in the form of a comma b and b comma c format, and a comma c will become 1 comma 2. That 1 comma 2 already we have written. Is it not transitive? I mean, not symmetric? Yes, it is not symmetric because 1 comma 2 belongs to R, but 2 comma 1 does not belongs to R. Obviously, whatever we wanted, that we have already noted. Then the last example is we need to prove that it is the relation R is symmetric and transitive. Symmetric and transitive but not reflexive, we should say. Symmetric and transitive, but it should not be reflexive. Okay, let us write the relation R according to the given condition. This is fifth sub question. I will say R5 is equal to, it should be symmetric and transitive. Symmetric means we should have non-identical ordered pair and the reverse of the same. If I take non-identical ordered pair 1 comma 2 and 2 comma 1, it will become symmetric. But is it transitive? Until unless we don't include a comma c, it will never become transitive. And can I say that the given relation is symmetric and transitive? Symmetric, non-identical ordered pair and the reverse of that. And we have one a comma 1 comma 1, reverse of that one is itself. Yeah, the given relation is symmetric and transitive, but it is not reflexive. Why it is not reflexive? To say that the given relation is not reflexive, the reason is we don't have all identical ordered pair for all the elements of set A. Set A has three elements 1, 2, 3. To say that the given relation is reflexive, we should have all the three identical ordered pairs such as 1 comma 1, 2 comma 2, 3 comma 3. We have only 1 comma 1. We don't have 2 comma 2 and 3 comma 3. Therefore, it is not reflexive relation. Clear? I hope it is very clear, and I have given the proper example for the given sub questions. We'll move to the next question. Okay, dear students, these are the last two problems under relation, and these two are the MCQs of NCERT problems. So here let us solve both the questions. Since these two are MCQs, so I had written both the questions one after the other. Let us finish this relations concept in this slot. So we have the first question as 20th one. Let R be the relation in the set 1, 2, 3, 4. That means a relation under the set A. Set A elements are 1, 2, 3, 4. Given by R is equal to 1, 2, 2, 2, 1, 1, 4, 4, 1, 3, 3, 3, 3, 2. Choose the correct answer. So they have already given the relation under the elements of set A. We can assume let A is equal to 1, 2, 3, 4. So here, never bother about the relation. Never go to options first. Whenever we are solving MCQs, first you go through with the given question and never look at the options, because in mathematics we cannot predict the answer. We have to solve the given question. Until unless you don't solve the given question, you can never compare your answer with the given four options, or without solving we cannot predict the given among the given four options which is the right answer. So what we have to do is, whenever we are solving the MCQ problem, first we need to understand the complete given question, and then we should solve the given question here. So see, relation R is given very clearly under the given elements of set A, 1, 2, 3, 4. Now to say that the given relation is, we need to check. So here options are based on reflexive, symmetric, transitive. In the all the four options they are saying, they are talking about reflexive, symmetric and transitive. So better you only check it, no? Better you only check it whether the given relation is reflexive, symmetric and transitive. Moreover, the elements are given. When the elements are given to you, it is very simple. We can easily identify whether the given relation is reflexive, symmetric or transitive. Let us move on to check. I will check first reflexive. Can we say that the given relation is reflexive? We have the four elements in the set A. To say that the given relation is reflexive, we should have all four identical ordered pair. That is 1, 1, 2, 2, 3, 3, 4, 4. Just cross check it in the relation R whether we have all identical ordered pairs or not. We have 1, 1, 2, 2, 3, 3 and even 4, 4. That means we can say that the given relation is reflexive. Finish. No doubt in that. So when you observe the options, so I better you complete the solution, then only you compare your answers with the given four options. I will move to symmetric. Can I say that the given relation is symmetric? First you observe whether you have any non-identical ordered pairs or not. If you have any non-identical ordered pair, the reverse of those non-identical ordered pairs should be there. For example, here we have 1, 2 and 1, 3, 3, 2. These three are non-identical ordered pair. But for all the three non-identical ordered pair, we don't have reverse of that. Which I mean to say, we have 1, 2 belongs to R, but 2, 1 does not belongs to R. That means the given relation is not symmetric. Okay, now let us move to the transitivity. Let us cross check the condition for transitivity. Is it transitive or not? Is it transitive or not? So let us consider 1, 2 and 2, something. 1, 2, 2, something means 1, 2 only we will get it as a C. In that case, the given relation will become transitive. And then if I consider 1, 3 and 3, 2, 1, 3 and 3, 2, 1, 3 and 3, 2, then A, C will become 1 and 2, 1, 2, which is already there. Okay, which means it is again transitive for 1, 3 and 3, 2. So can we say that the given relation is transitive? Do we have any such option that the relation is reflexive and transitive but not symmetric? R is reflexive and transitive but not symmetric. Yes, we have such option. Option B, I guess. Clear? Option B is the right answer. Yeah, option B is the right answer. Because here you take any two ordered pair which is in the form of A, B and B, C. 100% it will satisfy A, C as well. Accordingly, we can say that option B is the right answer. Now moving to the last problem in the relation. Last problem in the relation. I hope I have covered almost all the questions. So this is the last question. Let us see. Let R be the relation in the set N. N is nothing but natural number given by A, B such that A is equal to B minus 2 where B is greater than 6. Very major condition. B is greater than 6 and choose the correct answer. We need to identify the ordered pair A, B in such a way that A must be equal to B minus 2, A must be equal to B minus 2 and the value of B must be greater than 6. We have four options. Okay, we have four options. You take one such ordered pair where the value of B is, B is nothing but the second element. In an ordered pair A, B is to be considered as a second element. The second element must be greater than 6 we should have. So we have the four options. Among these four options, cross check which one is that option where the value of B is greater than 6. If I consider the first option, we have value of B as a 4. This 4 is not greater than 6. So I'm 100% sure that A can never be the right answer. When I consider 3, 8, so here the value of B is greater than 6 we have. It is not final answer. Let me cross check. 6, 8 is also given. This is also value of B is greater than 6 and even here also. So there are three options. Among these three options will be any one of the proper answer we will get. So condition is given very clearly that the value of A must be B minus 2. If I assume the second option, 3, 8 is to be assumed as value of A and B respectively. In that case, the value of A will become 3 and B will become 8. So if I substitute the same to the given condition, will it satisfy or not? That let us cross check. A value is what? 3. is equal to, b value is here 8, 8 minus 2. Does 8 minus 2 is equal to 3? 3 is equal to 8 minus 2. What is 8 minus 2? 8 minus 2 is 6. So it is not equal. That means the second option is also not correct. Move to the third option. What is third option? 6 comma 8 is given. Again we use the same condition. A must be equal to b minus 2 and b value is greater than 6. In the beginning only we have checked it. So I will substitute the value of a as a 6 and b is nothing but here 8. 8 minus 2. Yes, we are getting 6 is equal to 6. That means this is the right answer. Option C is the right answer. If you have a doubt, you can cross check with the option D also. It will not satisfy. I will show you that. A is equal to b minus 2. Here a value is 8 is equal to b value is 7 minus 2. 7 minus 2 is nothing but 5. Since these two are not equal, therefore option D is also not correct. So the correct answer is option C. I hope you have understood the entire relation concept. Dear students, this is how I teach all the chapters which is there in both first year as well as second year. Just I have started with the board syllabus. Once I complete the board syllabus, and then I can go with the CET, JEE level of questions for all the chapters. And this chapter is kind of theory. You may feel little boring, but upcoming chapters are very interesting, and moreover I have arranged the question in order, easy level to difficult level, and those who are watching the video, and I am damn sure that everyone will understand, whether you are a poor student in the sense whether you are below average, average or above average students. Every student can understand by understanding one or two problems as I am teaching. If I take one problem related to one type, and I will search all the problems which is given in the NCERT, and I will arrange one below the other in a difficulty to easy to difficulty level. In an order I have arranged so that every student can easily understand. I hope you have understood the entire concept of relations. In the next in the next video, I will come with functions and the problems related to that. Thank you.